Okay, so I think we are set. So I'm going to pick up from where we left it yesterday. Yesterday we sorted something. We ended at exception and logger. So our logging and our exception handling. So we set them up yesterday. So today we are going to start with the data ingestion. So I'll see that if we can do data ingestion and the data transformation part. Okay. So without saying so much, let's just begin with the data ingestion element. So that's one of the components in our machine learning model, the data ingestion component. So let's start with the data ingestion and see. So with the data ingestion, as usual, I'm going to start by importing some of the necessary libraries. So I'll import OS, also import sys, also from data classes. We're going to import data class. From data classes, import data class. Also, we are going to import pandas. So our data is in a CSV format. So pandas will enable us to read that. Also, we will be doing some train test splitting. So I'm going to import the module for that. So from sklearn, model selection, we're going to import train test splitting. So train test split. Then we will also import the file, our exception, that the module for exception handling, and also the module for logging. So again, from src dot logging dot, I think it's logger, import logging. That's okay. Any other imports when necessary time comes. So we're going to first define a data class that will hold the data ingestion configuration. So, and that is that. So this data class will hold data ingestion configuration. So let me just rename this as data ingestion config. Yes. So data ingestion config. So data ingestion config. That's it. Under data ingestion configuration, as we can say that it's going to hold the file paths to our data. That's the raw data, the train test, as well as the training set and the testing set. Okay, so this is what this class will hold that. So I'm going to specify the file path. Under here, I'm just going to say we're going to define the default file path for the raw testing. So raw testing and training data. So let's start with the raw data file path. So raw data file path, we can just say artifacts. So artifacts. So artifacts supposed to be TS. So os.path.join artifacts. This is our raw data. So we can just name it as raw.csv, raw data.csv. That's okay. Then you can also define the file path, train data file path. That's okay. Artifacts raw train data CSV. That's okay. And also the test data file path. I think that's okay. os.path join artifacts. So artifacts is the something like a folder that will be holding this data. Okay. So after creating the class, the data class for holding the file that will define our file paths, we are going to create another data class that will actually do the data ingestion part. So here we can just say create another class. So class data ingestion. So in our class data ingestion, we're going to define this. So here you can just say config data ingestion and self data config. So that's okay. Then we start now the process of initiating data into our system. So just creating a method. I just say my method is about initiate. Just name this initiate data ingestion. So initiate data ingestion self. That's okay. Then here we can now start using our log information. So we can just say login .info. Then inside this bracket, you just specify the type of message that you want to arise when we are reading this code at this point. So you can just say commencing data ingestion. So we want it to get a logging information about that. Then after this, since we used or we included the exception, so that's when we can call now our exception. So you can just say pass then for exception. We can say exception is supposed to be except exception as e. Then you can login. You can just say data ingestion failed, something like that, or you can say data ingestion failed. Then it will raise this error. So let's start writing the code here. So the first one will be about reading the raw data from the file. Okay. So our raw data, let's just call this as raw data. Let's call it as df. So read CSV is a CSV file. Then from the raw data file path, or so we can use this, or another way that we can do is to just paste. You can just paste the file path itself. Okay, so I'll just paste I've saved my data so I've saved my data in Google Drive. So as you can see, my data is home electricity bill prediction. I think it's this. And just open with Google Sheets. You can see that my data is this one, home electricity bill prediction. So this is my data. So what I'm going to do, I'll just I will just maybe let me download this so that it can be, or what we can do, let me first download this data. Supposed to be a CSV file. Let me download this data. There's another way that you can use the link. Just use the link to copy this data, but I'll show you that in a subsequent model. We'll show how you can just use the link to copy this. But for this, as I had alluded earlier, we're just doing the most basic. So the most basic of all will be just copying data from our CSV from our local machine. So I'm just going to create a new folder. I'm just going to create a new folder, not under components. I'm just going to create a new folder, and this folder I will label it. Let's label it as notebook. So under notebook, I'm going to after creating this folder, when you go to your local machine where you are you did the cloning, you can see we have the notebook folder. So I'll just go to my downloads, and then I'll just copy. This is supposed to be supposed to be a CSV file, so I'll just copy this, and then I'll just paste it here. It's supposed to be, I think, home electricity. I think that's it. So under notebook, you can see we have, this is the CSV. Let's see if you can open with the CSV editor. You can see that this is our date, so there's no problem. So this is our date. So what I'll just do under the data ingestion part, read CSV, then I'll just go to the new created folder, then I'll just copy the path. I'll just copy the whole path of our data, then I'll just paste inside here. So you can see envelopes, this one, then home electricity bill prediction, one CSV. So that's our file. I'll just do this. That's when it's irrelevant. Then by this, it will be reading our the source of our data. So after reading this, we are going to log another message. So we are going to log another message, and this one can say, for this one, we can say that logging.info, logging.info, supposed to be logging. We can say successfully read the data. So we can say that. So after logging our data, we can then create a directory. This directory for the train data. So os dot make this make directory. So I know this sounds a little bit complicated, but in one of the projects I'll show you how to, instead of no, I think we are just okay. Yeah, no problem. I just want to make for the train data. So os, make this os.path directory name self.config. So this one, self.config data train path. I think this one is okay. So if you want to include the others, for the other train data path and all that, you can also include them here. So then we can create another logging message to tell us that successfully created the train data directory. If you need the other ones, for example, if you need for the test data, you can just do the same. I don't think you can just do away with one. So logging this, then after we have logged our data, then the next step will be, after creating this, I think what I'll argue, I'll just do the complete this process, then we can. So after we create the directory for this, the next thing will be about save the data frame to the raw data path. So here we can just say df dot to underscore CSV. Again, you just say self.config raw data path. That's okay. Go to CSV index false, and you can also header be header true. I think that's okay. Then logging info successfully created the road. I think now we are okay. True, logging successfully. Then after this, we can now move to our train test splitting. So let's do the train test splits after this. now splitting the data into train test and train test data. So you can say let's use set, so train set and test set. So train set, test set, train test splits, the function that we used. So we are splitting our data frame df, test size 0.2, random set 42, no problem. Then logging info successfully splits the data. So then after this, the next one will be about we are going to save the train data and the save the train data and the test, save the train data to the train data path, so that's okay. Then train set to CSV, then that's okay. Index true, header to be true, that's okay. Then logging info successfully created the train data path directory. I think that's okay. So basically we started by first importing our data into the system. Then we used a logging message to tell us that. Then we created a directory for the train data. So creating the train data, we created a directory path for that. Then after that, we did our train test split, where we split our data into the training set and the testing set. Then save the training data path to the train data set to the train data path. Also, we can also do the same for the testing, for the test set. Okay, so test set. So we can just copy the same thing. So and copy this. Just test set to CSV self config is supposed to be train data path. Is supposed to be now test data file path index false, either true. Then successfully created the train, or you can say successfully exited the data splitting process. Successfully exited the data splitting process. Okay, so let me just confirm something. So then after this, we can set what we do, return the paths. So you can say return the paths to the train and test data. Okay, so again, for return statement, you can say return. So self.config row data file path. Okay, no problem. Let's return the self.config train data path and the test data path. I think that's okay. Then our exception. Okay. After we are done with this, we can then execute this file to import our data. So let's use the if. So if underscore name underscore. Nope, supposed to be then underscore main underscore. Then you can say first we create the config object. So config data ingestion config, that's okay. Then you can create something like an let me just change this to an object. So obj data ingestion config is equals config, or you can just do like this. So if underscore name, create the config object, that's okay. Data ingestion config, that's okay. Then you can just do obj.initiate data ingestion. logging info, data ingestion completed successfully. That's okay. Control save. So let's see. Let's execute this. So we're going to our terminal, new terminal. Then let's make command prompt our command prompt. So this is data ingestion part. So we're just going to copy the relative file path. Say Python src common components data ingestion.py. Make sure we have saved this. Let's execute. Once we execute this, you will see another directory here, and this directory will contain the test data, the raw data, and the train data. Okay, so let's execute this. So once this is done, you will see the chain. We will now see an artifacts folder. We'll create an artifacts folder, and this artifacts folder will contain the raw data part, the raw data, the train data, as well as the test data. So let's wait for it to execute. Okay. We can now see this is the artifacts. But in the artifacts section, you can now see that we have the raw data, test data, and the train data. So that means our data ingestion part is working correct. So if I may go over again. So we started by importing the necessary libraries, as you can see, the OSCs, data classes, and all that. Then after that, we created a class, and this class is holding or contains the necessary file paths. The data class contains the necessary file paths for our raw data, our training data, and the testing data. Then after this, we moved on to the data ingestion component, and this class, under the data ingestion class, this is the actual class that is going to perform the actual data ingestion. And we created a method for that. Then the first thing was about us reading our data. So we use this a link or a file path. You can see that this is the name of our data itself. So we read this. Then after that, we logged in. We created a log information to tell us that we have successfully read the data. Then after that, we move on to create some directories. And these directories, one was for the training data. You can also create for the other. Then we create after creating this directory, then we move on to save the data frame to save the split as a data frame. Then we split our data into the training and the testing data. So using the train test split, this is our data frame, our data. Then the testing size will be 20% of the data. The random states are 42. Okay. Then after that, we moved on to now save the train. We're saving the training data and the testing data. We just saving them alongside their paths. So their paths. After that, we return the training file path and the testing data file path. Then we can encapsulate this using our try block. We created a try block so that if we had errors, it's going to raise those errors. We saw yesterday how our exception handling will be working. Then after that, we can use the main block to execute our code. Okay, so that's it. You can see that after that, we are able to create the artifacts folder, and under the artifacts folder, we have the raw data, the test data, and the train data. So after this, I think we are done with this. The next step will be data transformation. So we are going to move to our data transformation, and you'll see the different steps for transforming this data. So if yesterday, let me yesterday we saw how we are going to do some pre-processing of our data and all that. So let me open that Jupyter file to see how we can achieve that. Okay. In the meantime, maybe I can answer some queries. So we can now do our data transformation. Okay. So for the data transformation, again, I'm going to start let's start with the let's see. Let me do away with this Anaconda prompt. So task manager. So what we can do, let me show you something here. So under so while that is opening, let's start our data transformation. So again, I'm going to start by import. So import OS, and then import sys. Again, from data classes, import sys. Then from data classes, import a data class. Also, I'll import numpy. Also as np, also pandas again. As pd. Under the data transformation, we'll use several. I'll import the necessary things. So I'll also import this. Then in the data transformation, you're going to use a different modules. So sklearn dot compose. We're going to import column transformer. That will be necessary. Again, we are going to import from can import the simple imputer. You can also import a pipeline. So from sklearn pipeline, we're going to import pipeline. We're also going to import from pre-processing steps. So again, from, don't know if this is just close this. From sklearn, we're going to import processing. We're going to import standard scaler. First one will be the standard scaler. The first will be the standard scaler, and also one hot encoder. Also another thing, simple imputer, pipeline, column transformer. Okay. Another thing. That's it. Test splits, we don't need it. So the first thing will be, we're going to define a data class to hold the data transformation configuration, to hold the data transform configuration. Data transformation configuration. So data class data transformation. I think we don't need this. Under this, we're just going to state where we will be performing or will be storing our reprocessor object. Or before we do that, we can just do pass for the meantime. I'll show you why. Then after this, we can also define a class to hold the data transformation pipelines and all that. So this one will be class a data transformation config. Just use a data transformation. You don't need the pipeline as of now. So I'll show you in the subsequent models. I'll also show you how to build these pipelines. So here, I think I won't need this. So def init underscore self. So here we can also say data transformation config, data transformation self init self. Just do this, then end it like this. Then here we can just say self dot data transformation config, and specify like this. Then we just do this. That's okay. So yeah, I think that will be done. After this, we now start create the method itself. So def initiate data transformer object. So find get data transformer obj object itself. Supposed to be self. Okay, so that's okay. Then we're going to initiate our try block. So try pass. Then accept as e. Then raise. Well, we'll just say this. then E, if I'm not wrong. It's E, sys. Oh, I forgot to do something. And after we have finished with our data ingestion, we need to push this code to our GitHub repository. So, or let's do the data transformation part, and then after that we can push. But I usually advise that if you finish a component, you push your data or your code to the GitHub repository. Then after this, after the pass, we start with the data ingestion. Then we can first separate the numerical and the categorical columns. So we can say numeric columns, this and this. But I want to pass so I just go to our raw data. So for our under the artifacts folder, let's create a new the notebook. Let's create a new file and say tools.py ipynb. Okay, so for the ipynb, we first have to say import pandas as pd. We also say import numpy as np, but we need to Python environment, so we are using this. Then we need to activate our Python environment, then ipynb. But in the meantime, as this is loading, let's import our data. So when we import our data, we'll just use df pd dot install a kernel. So pd dot read csv. Then we'll just use the same thing as we did in the data ingestion. So we are just going to read this. Control C, and can do this. So after reading our data, the next cell will be df.info. Then the next cell will be numeric columns, or you can say but we still have our data. We can just do it manually. So let's say you can see that fan, refrigerator, air conditioner. So fan, refrigerator, air conditioner, television, monitor, pump, the monthly hours, tariff rates, and electricity bills. All those are numeric columns. For categorical columns, you have city and company. So you can just do this. For categorical columns, create a list for that. So it was city. So city. Then we have company. Then for the numeric columns, can create a list for that. See fan. We have fan. We have refrigerator, air conditioner. So refrigerator, air conditioner. Refrigerator, air conditioner. Air conditioner. Again, we have television, monitor. Television, monitor. Also, the next one is about motor pump and month. So motor pump, month. We also have tariff rates and electricity bill. Tariff rates. Also tariff rates. I will leave out the target variable as of now. So let's see, tariff double F. Double F. So we have listed our numeric columns and the categorical columns. And fun, they're supposed to be 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, with the exception of the electricity bill. Okay, so we have our numeric columns and the categorical columns. So after we have done that split, then we need to create a pipeline for numeric columns. So create a pipeline for numeric columns. Then here we can say numeric pipeline. In numeric pipeline, you can say pipeline supposed to be caps. So pipeline the different steps. So for the steps, we can start by imputing missing values. So when imputing the missing values, we are going to use the simple imputer. So I'll just create imputer, simple imputer, simple imputer. Then we need to specify our strategy. For strategy, I will use median. So the median value will be used to fill those empty spaces. Then after that, we will do scaling. I'll use the standard scaler. So this isn't that complicated. So for scaling, I'll use the standard scaler. So I'll just say so scalar, specify we're going to use the standard scalar. I think that's it. So the scalar steps. I think so. After doing the simple imputing, we do the scalar. So that was for the numeric pipeline. Then again, we're going to create a pipeline for categorical columns. The categorical columns. So cut pipeline. Again, we're just doing the same thing. Pipeline. This. So the brackets, we define the steps that we are going to take, and under the steps you're going to start by imputing. You can also just cancel this, we don't need it anyway. Okay, so imputer. So the imputer, we're going to start with a simple imputer. So imputer simple imputer. Then we're going to say, again, we need to specify the strategy. So strategy strategy will use the most frequent. Most frequent, yeah. I remember here we need to use commas, so we can use comma like this. So with the categorical pipelines, we need to use the one-hot encoding. So we encode those categorical values. So our one-hot, again, we'll just say one-hot. This one will be one-hot encoder. Then here we'll handle unknown. This one we just ignore. Then the most frequent supposed to be strategy. We are missing something. So all of this should be in the bracket like this. So all of this should be the brackets, inside the brackets, all of this should be inside the bracket. So one-hot order, ignore, that's okay. Then you can also add a scalar, but I don't think it is necessary, but let's just add it, because these are just sparse matrix. These are matrix of zeros and ones, so is a scalar important? But if you have to use a scalar, then you can use the standard scalar. Then you can specify with mean false. So one-hot, okay. So then after this, we can So after creating the pipeline, numeric and the categorical columns, we created the pipeline for those. Then we can create a logging message to tell us if this process is successful. So logging .info. And say data pre-processing complete. After this, we need to merge these columns. So create a column transformer. Combine the pipelines. So you can say a preprocessor. Let's call it just a preprocessor. So preprocessor, and then we call our column transformer. Column transformer. Then you can say transformers. Then we can say the numeric numeric columns. So now just say numeric pipeline. Apply this to the numeric columns, and this one should be inside. Okay. So after doing this, you can also say the categoricals. But you can also say that and tell our column transformer that look at the cut pipeline and see the necessary steps that we are taking. So use that steps, apply that to our categorical columns like that. Then from here we can now create our logging message. We can just create a logging message and say logging.info. Here we can just use an F string. So the processor object. Preprocessor like that. Then we can return our preprocessor. Let me see if everything is okay. I think that's okay. That's okay. after this, so let's continue the next step. So after we have after we are done with these pre-processing steps, so this is the initial pre-processing that we need for our data. As you can see, we have the numeric columns and we also have categorical columns. And we all know that our model is not going to accept strings as input. So we need to do some pre-processing. And for the pre-processing, I've decided to use the one-hot encoder. You can use the label encoder on any other encoder. So as first, we created a list for the two types of columns. We have numeric columns, and then we also have the categorical columns or the categorical attributes. So we splitted that. Then from here, we use our pipeline. So for the pipeline, we said that for the numeric pipelines, the first thing that you need to do is to look at those columns to see if you are missing some values. If you are missing some values, use the simple imputer with our strategy min to try to impute those or fill those empty rows or in those columns with I think with the median value in that column. Then after you're done with that, we pass that through a standard scaler. For the categorical column attributes, we are first doing a simple imputer, and we're using the most frequent value in that column. Then after we are done with that, we can do the one-hot encoder. This step is not really necessary, or you might leave it, or having a column with zeros and ones, I don't think this step is necessary. So you can just highlight that out, okay? Then after we are done creating our pipelines, we need to merge these pipelines together so that we create our final data. And for this data, we are using the column transformer. It's going to merge these columns along the column axis. So we are using the column transformer. Then we are telling our column transformer, do you see the numeric pipeline? So just go to our numeric pipeline with our numeric columns. Just do what we have stated in our numeric pipeline. And once you're done with that, go to our categorical pipeline, do what we have instructed you to do there. Then after that, you can merge these two sets into one. Then you can return your preprocessor object. So this preprocessor object will be important because when we accept the user input, we might accept user input for the city and company. We might accept the user input in terms of a string. So we need to again take this data, pass through our preprocessor before we before we try to predict. So after doing this, we then move on to the next. So I'm going to create another method, and this method will be all about initiating the data transformation after the preprocessing. So I need to ensure that I'm at the correct. So we are going to initiate now the data transformation part. So initiate data transformation. So initiate data transformation. So we can say self. Then our parameters will be the train path. So the train path and the test path. Train path and the test path. Train path supposed to be path. The test path. So that's it. After we're done with that, we can now again issue our try block. And I can just copy this. So try block, then you can say pass. And this. Then you start read the train and the test data. So we are going to read the train and the test data. This will be using this paths or these parameters will be our variables for storing the training data and the testing data. So you can say train df pd.read csv, then you can pass in the train path. And after this, you can say train df. Then this one should be test df. So we can also say pd.read csv, then test path. So that's it. Then after reading the train and the testing data, we can then log our message. So logging .info and say so at this process we have exited reading, training and testing data sets. Training, testing data sets. So that's it. Then in this process we'll obtain our preprocessor object. So let's call our preprocessor object. So we're going to, let's say, get the preprocessor object. So preprocessor object, this will be self dot get data transformer object. So this initially it will preprocessor object will come from this method self.get transformer get data transformer object. So after doing this process, we need to save our preprocessor, and after doing that, this one will initiate this process, and this process we are going to save our preprocessor object under this. Then we need to create something like a file path where we are going to store our preprocessor object. That's why I said that this one we need to leave it at path. But at this moment, you can now see that we need to save this preprocessor object that we are creating. So I'm going to create the preprocessor object path. So preprocessor object file path. So the file path will be os.path .join. I'm just going to save this under artifacts. And I'll give it a name, preprocessor joblib. So I'm using the joblib format to save this process. So this is just the name of the preprocessor. So after calling our preprocessor, we can now define our target variable. Define the target variable. So for our target variable, you can just say target column. So our target column under our this is the electricity bill. That's our target column. So I'm just going to call that and say target column, it is electricity bill. Electricity income, electricity bill, electricity bill. Okay, that's okay. Target column electricity bill. Why are we having an error? What's this? Am I missing something? What's up? I'll do. Let's try something. Just shut this down. Try to open it again. So error seems to have gone. So define the target variable. The target variable, we can just say target column. This one will be electricity bill. That is our target column. I'll just increase the font. So target column electricity bill. And then after this, we need to drop the target column from the input features in both training and testing set. Getting the same error again. What's not happening? I think it's problem with indentation, if I'm not wrong. Okay. Computer. and say file operation error. Basically, it's affecting both. Let's execute this file to see. We can say Python. So let's see if we are going to get the relative path. So I'm just C dot components data ingestion dot py. Control C, then let's see if you're going to get an error and see what the error will look like. But I don't think if there's something wrong here. And the except block is okay. As E, okay, sys. We are still getting the artifacts. Jason with comments. Don't know why. Run this, you are getting successful. But let's just continue and see if we will encounter an error in our overall code. So target column electricity bill. Then after this, we are going to drop the target column from both input and from both training and testing data sets. So training input features. Then you can say train underscore df dot drop. We're going to drop columns then we specify we're going to drop the target column along the axis equal 1. What about then you specify training target feature. Just specify if you train df target column, that's okay. Then our testing input features, that's okay. Test df to drop column target column, okay. Then testing input features, that's okay. Then we can log a new message here. So logging info and say that a data transformation complete. No, we need first to apply the preprocessor. So applying the preprocessor to the above data. So here we can say training inputs, the training input features array. So it will be something like an array, training input features array. Then you can use the preprocessor underscore obj. Then you're going to fit and transform. Fit and transform training input features. So these are the features that you're going to transform. And you're going again to testing input features array preprocessor objects. So we're just going to transform the training for that. Then we can add another log message, logging info data preprocessing complete. So that's okay. Then after we are done with that, we can concatenate. After this, we can concatenate the transformed input features with the target features for both training and the testing set. Okay, so we can say or here we can some printing, printing into brackets. Like something like this. Then we can call this training input as array. I don't think this is necessary anyway. Okay, concatenate this. So you can say training. So training array. So this one will be using numpy. So we can say training input features array. Then np dot array for the training target feature. And we're going to repeat the same thing for the testing array. That's the same testing array, testing input feature array, np dot array testing. That's okay. Then after this, we can saving the preprocessor object. So logging dot info, you can say saving the preprocessor, saving the preprocessing objects. Preprocessing objects. So for this case, the objects, let's say, or we can just say something like that, save underscore object. Then we specify the file path. So file path self dot data transformation config dot preprocessor object file path. Then we can say something like the file type, the job lib object preprocessor object. That's okay. Then for the save objects, we have our utils function. So we can go to our utils function and create some function that will be able to read our object. So in the utils function, so I'm going to import os, import sys, also import joblib, because we are saving our model as a joblib. Okay, so we are going to ensure that we are creating an object that we're going to save our object. So for this case, we are going to, in our utils, we're going to create a function that we're going to save the object. And if we need to read this object, we can then just recall that function and it will be doing that the same. So we are going to first define a function that will help us, that will save the object in a file. So def save underscore object, and it will accept file path as input, the object itself. Then again, you can use the try block. In the try block, we can start by get the directory path. So get the directory path. For this path, we can say directory path. This path os dot path dot directory name. This is the file path. And if the file path does not exist, we need to create it. So if the path does not exist, what you can do is create that. So os dot make the directory. So the directory, so dir path, dir directory path, then exists, okay, true. If the directory does not exist, then we use this line of code to create that directory. But if it's there, we need to now save the objects in the file. So with open file, will be as file object, save the object as the file, joblib.dump obj file obj. So that's okay. And then we can handle close this with the exception. So except as e, space file operation error sys supposed to be E, accept exception as E. Rise file operations error, file operations error as E. But for this case, we need to copy the exception handling, this one. We need to copy it into our utils so that we are able to do away with this error. From SRC exception, import file operations error, file operations error. Supposed to be file operation. Import sys, import OS, import sys, joblib. I think there's an issue with this, the sys. But we might not execute this code today, but let's just save this. So we need to import this function now to our data transformation. So here we can call that. So again, from can just call it from here. So from src dot components dot nope, components. The utils is in src dot utils. Yeah, utils import save object. When we save that, you can see that yeah, now we are okay. Save the object. Then after this, we are going to return something. So for the return, we can say return. So we are going to return, I'm just going to return the training array and the testing array. So training R and also the testing array and the preprocessor object. So we just go self dot data transformation config dot preprocessor object file path. Then after this, the exception. So I think we are okay with this. So we can just go to our data ingestion. Don't know what is causing these errors, but I will look into it. But maybe you can, because of the, I think it's monotonous, so we can just maybe end the session at this point. But for the next session, we will start. We'll start by first, but before, let's just try to execute. Let's try to execute. So we can just comment this. After the data transformation, we can so if underscore name underscore that underscore main underscore. Then we can call the config data ingestion config. So also be data ingestion configuration. And from here we can call the object. So data ingestion config. Then we can call the train data test data. Do we have these things? Obj dot initiate data ingestion. Then for data transformation, for data transformation, we need to import the modules themselves first. So we will import these modules from a data transformation. So from data transformation, we need to import some modules. So import SRC components, data transformation, trainer config, and data transformation. Then we are going to call them here. So data transformation and data transformation, initiate data transformation, train data, and test data. Train data, test data. I think we're okay. So we can try to run this. Control save. You can say Python src dot components dot data ingestion dot spy. Let's see if you're going to get something. Otherwise, if you're going to get an error, I'll just go through this code again. Then in the next session, we will start from here as we proceed to the now model trainer and the prediction pipeline. So we are getting an error, modules is no attribute exec. So you can see that this pack training input features array, we are saying that all the input array dimensions except the concatenation axis must match exactly, but along dimension 0 during handling. Okay, so the problem is arising from here. Okay, so now we see where the error is coming from, but I'll work on this so that when we meet in the next session, we'll sort this issue, then execute this code so that we do the pre-processing. We create our pre-processing object. Then the next session will be all about the model trainer, and possibly we do the prediction pipeline. Then from there we can build our app that will accept user inputs and all that. Okay, so I think you, at least by now, you can able to go through and see the steps that we have taken during the data ingestion component as well as the data transformation component. Once again, thank you for your time. Thank you for joining me. Before we end the session, please consider to subscribe to the channel. Your support really motivates me to do more of this. So please consider subscribing to the channel. Hit that notification bell so that you never miss any of our video updates. Until next time, I'll see you.